everyone says, well, it must make you cold, right? Well, if you stay in there a long time, you become hypothermic, right? But let's remember the thermostat example. You have a little area in your brain called the medial preoptic area. And if you make the surface of your body cold, guess what happens? Core body temperature goes up. So if you're going to do ice baths or cold showers, you can do, I would say, do them sometime better than not at all. There's a beautiful paper published in the European Journal of Physiology in the year 2000, which took people and had them sit. They actually had them on lawn chairs in water, a pool. It was a great way to run an experiment. I always say, people ask about cold showers. There are not a lot of experiments on cold showers because think about it, it's very hard to control. Is everyone under the shower the same way, et cetera? You put someone up in water up to their neck, you know what you're doing. So it's experimental rigor that drives that. But they had people get into reasonably cool water, 60 degrees Fahrenheit. So it's not that cold, but they had them stand for an hour. Or they've had people get into very cold water, something like 40 degrees, for just 20 seconds. Now here's what's really interesting. That shock that you referred to is adrenaline, also called epinephrine. And it is released from the adrenals, obviously, but also from a site in the brain called locus ceruleus, a little area of the brainstem that then sprinklers the rest of the brain with epinephrine and wakes up the rest of the brain. So that shock occurs in the brain and the body, and actually the stuff in the body doesn't cross the blood-brain barrier. So you're a two-part system.